I'm Anil Kumar. Welcome to very special series which is Power Series. This is for advanced level of calculus and all those students who are seeking admission to excellent universities. Now we'll try to derive the formula for ln1 minus x, which you know is minus x square over 2 minus x cube over 3 minus so on, which could be written in the summation form as given here, where absolute value of x is less than 1, right? So when you have to derive such a formula, when we are working with these kinds of series, we have to bring all our knowledge of derivatives, integrals, binomial theorem together to solve them, right? Now, what is the derivative of ln, what is d dx of ln 1 minus x? Well, the derivative of this is 1 over 1 minus x with a negative sign, right? That is what it is. Okay, so basically, if I say what is the derivative of negative of this, so what is the derivative of negative of d dx of ln 1 minus x, then that is of course equal to 1 minus x, right? So why am I writing in the form of 1 minus x? That's a big question, right? Why are we writing? Mainly because we have just derived the formula for writing 1 minus x as a power series, right? So here is a reference which I am providing you, and we have just learned that 1 over 1 minus x could be just written as a simple power series, 1 plus x squared plus x cubed plus x to the power of 4 plus so on, right? So that is what we learned. Now in this particular playlist, you may have to go back to see the connection, because many formulas will be derived from what we have already got, right? So it's a very complicated subject, so I like you to go in a sequence so that you really get the gist of it. So basically, we are trying to figure out, we know this particular function, we started with this, our power series, right? And it gave us a clue that somehow we could link logarithmic function with this, so we are trying to manipulate it, right? So when we write like this, we could also say that reverses integral. So we could say minus of ln 1 minus x should be equal to integral of 1 over 1 minus x dx. Does make sense to you, right? So it does, I hope, right? So that is the whole concept. And now we know what this function is. This is simple polynomial combination of infinite elements, right? Now that could be easily integrated, correct? And rewrite the whole function in the form of a power series. And now it is very easy to integrate, correct? So let's integrate and try to solve it. So what we have now here is ln 1 minus x is equal to integral of, let me write this as the power series, 1 plus x squared plus x cubed plus so on, right, dx. So that is equal to, so integral power rule, right? So we get x plus x squared over 2 plus x cubed over 3 plus x to the power of 4 over 4 plus so on, and plus a constant c. So that is what we get. Now to find the value of c, what can we do? Well, we can actually replace, and also remember one more thing, very important here, is always to keep in mind that this series is converging for absolute value of x between plus and minus 1. So we always remember that this is less than 1, right? Okay, so that is how it is, where absolute value of x is less than 1. Okay, so if I write here x equals to 0, if I write x equals to 0, then what happens? In that case, I could always write like this, minus ln 1 minus 0 is 1, right, equals to, this is 0 plus 0 plus, all these are 0, right? We just get c here. So, and what is ln1? ln1 is also 0, right? So that gives you that c is equal to 0. because ln1 is 0. ln is log to the base e. So we get c equals to 0, and therefore now I can write ln 1 minus x with a negative sign is x plus x squared over 2 plus x cubed over 3 plus x to the power of 4 over 4 and so on, right? C is 0 now for us. And what happens when I multiply by the negative number? I get ln 1 minus x as negative of all this. Negative of x squared over 2, negative of x cubed over 3, right? Negative of x4 to the power of 2 plus so on. Do you see? So ultimately we have proved what is ln 1 minus x equal to. You get the idea, right? So we'll call this as our formula number 3. Right, so that is our formula number 3. And now, if I make a small change, that is to say, if I replace x with minus x, then what happens, right? So let me make this change here. So if I substitute x with minus x, then what happens, right? So if I substitute that, then I get ln of 1 plus x. Do you see that? Equals to, that becomes positive, right? And I'm substituting x as minus x. So this remains, this becomes positive, but this negative remains as such, okay? And this becomes positive, right? So we get x cubed over 3. That remains as negative, x to the power of 4 over 4, and so on. And we get our formula number 4 for ln 1 plus x. Does it make sense to you? So we have derived the formula for the expansion of logarithmic function, right? So in many questions relating to even limits, derivatives, and integrals, we could write logarithmic function with this combination of power series that will help us to solve those questions very easily. So I hope you understand the power of what we are getting into now, right? Feel free to write your comment, share your views, and if you like and subscribe to my videos, that would be great. Thanks a lot for watching and all the best.